Okay, now we are at the last problem. Suppose that we've got 8 different prime numbers. Okay, they are expressions. We've got x, y, z, and w, and the 8 expressions are 8 different prime numbers. And we also have this equation, and we have the restriction that y and z are both less than 50, and we're gonna find the value for w minus y. So basically, we're looking for w and y. And let's see. Or maybe there are different possibilities, and that's why this is asked. But I don't think that is the case. Okay, but anyways, it's kind of fun. It's a number guessing game. Let's see what we can do. So first of all, when we come across a bunch of prime numbers and we see some plus things, we suspect that there might be 2. Yeah, well, what I mean is this. See, x is a prime number, and x plus y is also a prime number, right? And y is a prime number. If this is an odd number and this is an odd number, then x plus y would be a big even number, and big even number cannot be a prime number. That means that among x and y, one of them has to be 2. Okay, and for the same reason, we've got x and z here. So x and z, and also x plus z. So among x and z, for the same reason, one of them has to be 2. There's a 2 here, and there's a 2 here. And since all numbers are different, so only one of them can be 2, which obviously is x. X is a common in both places. So x is a 2 for sure. And after that, we've got y plus 2. And y plus 2 is a odd number because y is an odd number. So there's no big difference, no big problem. So let's rewrite these numbers now. What is w? Let's use this formula. It's an equation. It's an equation. X is a 2. So w would be 232 minus y. Okay, so the first one, 232, because x is 2, is moved over. So it's 232 minus y would be, this is actually w. Later we will know this. And when we might need to use this. But for now, let's just write this. And we want to use as few variables as we can. So we just use a y instead of a w. And x is a 2, and this is a y, and this is z, and this is a y plus 2, and there's a z plus 2, and there's a 234 plus z and 234 minus z. Okay, they are a group, and later we're gonna use them, plus z and 234 minus z. Okay, that's everything we've got. 1, 2, 3, 4, 5, 6, 7, 8. And this is a prime number already. We don't have to worry about that. And also we've got that both y and z are less than 50. This is very useful. So let's check everything under 50. And of course 2 has to be excluded because it's used already and there's no repetition allowed. Now list everything out and see what we can do about y and z. Okay, that is everything. And you see, y is a prime number, and y plus 2 is also a prime number. And similarly, see, it's a prime number and another prime number, right? That's kind of a twin prime numbers. So let's see which of them are not possible and which of them are possible. So in terms of y and z, 3 is possible because 3 plus 2 is 5. So 3 is okay, retain. Keep this one, not this one, because 7 plus 2 is 9. So 7 cannot be either one y or z. This one has to be crossed off. 11 is okay. 13 is not okay because 15 is not. This is okay. This is not okay. 21 is not. This is not okay. 25 is not. This one is okay. 33 is not. 39 is not either. 43 is okay. For itself, it's not okay because 45 is not. And this is not okay because 49 is 7 times 7, which is obviously not a prime number. So that's all possibilities for y and z at this moment. And okay, so this part has been used already. So we don't have to worry about this anymore. And this is not useful any longer. And let's move on to this part. 234 is just 1 below multiple 5. That is to say, it is congruent to -1 mod 5. in that case, we've got a plus z and a minus z. So z cannot be too close to 5. If it is just 1 away from any multiple 5, then this couldn't be the right z. So this is not the right z because it's just a 1 over a multiple 5. And this is not, this is 1 short of a multiple 5. This is 1 over a multiple 5. So all three of them has to be excluded as a choice of as the value of z. And how about this? 3 is not okay because 2, 3, 4 is a multiple of 3. That is why z cannot be 3 either. So this could be z. This is not z, and this could be z. Okay, now we have got only 2 possibilities in terms of z, and we will keep showing that one of them is not okay. Which one? Which is this? Because if we consider 234 minus z, which is minus 17, in that case we would have this number, and this number is obviously a multiple of 7. So this is not a prime number. So z cannot be 17. So the only one left here is a 5. So z is 5. It's already found. Z is 5 and this is a 7. Okay. And let's now consider y. Okay. Because y doesn't have this. So the 3 of them might be y. One of the 3 might be y. But since z is 5, so the 5 is already used. We cannot use this. And we have 1, 2, 3, 4, 5 different possibilities for y. And can y be 3? No, it can't, because y, if y was 3, then y plus 2 would be 5, but 5 has already been used. So this one has to be excluded, okay? This can't be y. This could be y, this could be y, and this could be y. And let's see, maybe it's time to use this. Some of them, let's see, 232 minus y. If y is 5, no, I mean not 5, it could be 11, or it could be 29, 17, it could be 29, it can be 40, 41, it can be 41 as well. Okay, so 41 as well, but later it's not actually that good. Now we have 4 possibilities for in terms of y, and this value would go to 221. This is a 215. Okay, this is not good. Okay, obviously this is a 203. Okay, this is a 2191. Okay, and some of them might not be a prime number. Let's see. This is not a prime number because it's a 170 plus 51, so it is a multiple 7. It's divisible by 7. Let's see, when it's divided by 7, it is 1 and 51, it's a 13. Wait a second, the 2, I mean 2 or 14, 117, 7, I mean, sorry about that. Yeah, that's what I'm talking about. 17, that is not divisible. It is divisible, it's not a prime number, so this is not okay. This has to be excluded. And among these 2, let's see, what if y is, wait a second, okay. So let's see, 2 different possibilities, and let's see what this number is, because there might be some repetition. We should take that into consideration as well. This is large enough, we don't have to worry about that. But when it goes down, it's 229. Okay, so we cannot have another 229. Okay, for sure, there's no another 229, because these 2 numbers, when deducted, when we deduct any of this from the 232, there's no repetition and there's nothing to worry about. So let's see if both of them are prime numbers. 191, is that a prime number? Wait a second, let me think. It is a 13, 9, it's a 7, no, not 7, 51. So it is safe. How about this one? This one is not a prime number because this one plus 7 is 210. And 210 is a multiple 7. So this one is a multiple 7. This one is divisible by 7. It is 29. So this one is not prime number. So there's the only possibility. That is to say y is 41. Y is 41. This is 43. And this would be 191. Okay. Just double check and see everything is a prime number. This is, of course, there's no repetition, right? a prime number. This is a prime number, prime. Okay, let's see if this one's prime. 199. Okay, well, not 1991. 3 is okay. 5 is okay. 7 it's okay. 51 it's okay. And 11 it is okay. 81, right? 13, 61 it is okay. And the next one would be over the square root of this. So that's everything checked. Okay, so this is a prime number. The next one, 229, and okay, let's check 229. 3 is okay, 5 is okay, 7 is okay, 19. 11 is okay, it's just a 9. 13, it's 99. Wait a second, is that? Yes, it is 99, so it is okay. And then 17. 17 is already over. 17 squared is already over this number, so we don't have to check 17. This is done. This is a prime number. And finally, let's check this number. 3 is okay, 5 is okay, 7 is 29, okay. 11 is 19, okay. 13, that is 109, which is okay. This is okay for sure. And the next one, is it higher? Yes. The next one would be 17, and 17 squared is higher than this. So this is checked, and this is a prime number as well. So prime number, everything is prime number. So we've got everything here, and we need a W minus y. And what is w? This is w for sure. So this is 199. What is 9? What is y? What is y? Y is 41. So this is 41. This is a w minus y. This is 150. Do we have a 150? Yes, we do. So the answer is B, 150. In fact, you have to find out everything. And this one is it's just a way of asking a question. It bears no special meaning. You basically need to find everything x, y, z, w, and then tell the answer. So you start with the 2, and then you have to list everything under 50, every prime number under 50, and you should consider these two numbers. These are very important, and then you exclude something. And finally, you end up with the, of course, you need to try a little bit, and you have to double check and to make sure that there's, first of all, no repetitions, and secondly, every number is a prime number, and that's it. So this is not a hard problem, but it is quite fun, number guessing problems. And there is a sum number series, so it is fun. Okay, so that is everything for grade 7, and I will make another video, another series of video about grade 8 problems. I will see you later, and bye for now.